So if you could tell me your name.
I'm John Cassano, and I am an assistant professor at the University of Colorado, and I study polar weather and climate.
And what are you doing here in Antarctica?
I'm currently in Antarctica working on two projects, actually. One is working with weather forecasters over at McMurdo Weather. I work on developing the computer models that they use for forecasting the weather, and so I'm here to sort of see how the model is working for them, what types of new products we can develop to help them improve their forecasts. The other project that I'm working on is the Antarctic Automatic Weather Station project, which is based out of the University of Wisconsin, and I'm a co-principal investigator on that project as well.
How long has that automatic weather station project been in existence?
It started at the University of Wisconsin in the early 1980s.
Uh-huh. And how many stations are there?
It's something close to 70 around the continent right now.
Oh, great. And why did that start?
In the early days, there was, I guess, two motivations for the project. One was sort of an operational weather motivation that in order to forecast the weather well, you need to know what the current conditions are. Mm-hmm. And there are very few observation sites around the Antarctic prior to installation of these automatic weather stations. And so forecasters would have observations from McMurdo Station and South Pole and maybe a couple of field camps, and it really isn't enough to give you a complete picture of what the atmospheric state is. So you have a hard time making a good forecast. Mm. And so there was that motivation to put in weather stations around on the Ross Ice Shelf near McMurdo Station to give the forecasters a bit better sense of what the local weather was, so that when they made a forecast, they had a bit more confidence in it. The other aspect to it was the Antarctic is one of the biggest data voids in terms of weather data, and so putting observations there sort of helps fill that data void. And for the global weather forecast models, they need to know what's happening in the global atmosphere to initialize them correctly. Mm. And so having a data void in the Antarctic impacts even global weather forecasts. So,
does as a modeler, does weather in the Antarctic have a big effect on global weather, or is it mostly a local thing? I mean, I've been reading this Alone. I've been reading Bird's book Alone, and he like says that the Antarctic or the poles is where weather is made.
Right.
You know, he wrote that, I guess, in 1938, and I'm wondering if that's still true, or
it depends.
Or people think that, yeah, still.
It depends on sort of the scale that you're thinking about. Mm. If I'm forecasting weather in Colorado, the current conditions in Antarctica doesn't make a difference for a 2-day forecast for me.
Okay.
But on longer time scales, that's important. Mm. The atmosphere communicates across wide distances over, week to month time scales. And so if you're making a longer forecast, you really need good data further and further afield from where you're interested in making your forecast. Mm. Probably for forecasting Colorado, I don't really care about what's happening in the Antarctic, but for the southern continents, Australia, New Zealand, South America, South Africa, that will have an impact on their sort of week duration weather forecasts.
But it's really not especially important the way maybe Bert thought it was. I mean, Australia is just as important as the Antarctic, or there's nothing really super special about Antarctica as a weather maker?
No, I think there is. If you look at how global climate works, the reason that we have storms and weather systems is that the atmosphere is trying to balance the difference between heat loss from the polar regions and heat gain in the tropics. And so those storms ultimately are taking heat from the tropics and moving it to the polar regions, taking cold air from the polar regions and bringing it to the tropics. And that mixing, that exchange of heat, is driven by the temperature gradient between the tropics and the poles. And so, you need both halves of that. And that's really what drives the weather we have in the mid-latitude. So in that sense, that it certainly is a reasonable statement that he made that, the poles are where these weather systems are born,
Wow.
So
How does that happen? I mean, why are weather systems born in the pole? Just because of the unique geography, or?
it's mostly that they're just the poles are just the other half of that temperature gradient,
Okay.
and that temperature gradient is what drives all of the atmospheric circulation. And so, if you change the polar regions, if like in the Arctic you start to melt sea ice and you get warmer conditions there, you've changed the pole to equator temperature gradient, and you change the intensity of the atmospheric circulation. You change the intensity and character of storms.
Oh.
And so,
And have you been seeing, since you've been monitoring the weather here, and I know you've been doing some stuff in the Arctic too, have you been seeing a lot of changes, or?
in the Antarctic, over most of the Antarctic continent, we haven't seen a lot of changes.
Mm-hmm.
The exception to that is around the Antarctic Peninsula, where there's been massive warming, there's been loss of ice shelves, things like that. In the Arctic, the warming that we've seen in the last several decades has been pronounced. There was a similar period of warming in the Arctic in the 30s, and then cooled down, and it's warmed up again. And so there's some concern that the warming there is part of a multi-decadal cycle, not an indication of global warming. But the character of the warming that's taking place now is a bit different than what happened in the 30s, which makes scientists think that this is actually part of global warming. It's not part of a longer cycle.
What's different about the character, that it's just more extreme?
It's more intense, and the warming in the 30s was very localized in just the Arctic, and there wasn't much of a signal in the northern mid-latitudes. The warming that we've seen over the last couple of decades has been largest in the Arctic, but has occurred over a much broader region of the northern hemisphere, and so it has that different spatial character.
So in terms of understanding weather in Antarctica, do you feel that enough through these automatic weather stations and also the weather observers, do you feel that there's enough information there at this point that's coming in as far as what's happening? I say this because I was talking to Michael Carmody at the pole, and he was saying, "Oh, we need more."
Yes. Well, I don't think you'll ever come across a scientist that says we have enough data,
right?
And we don't need to make more measurements. And certainly that's the case in the Antarctic, I think, in terms of atmospheric observations. The weather stations are great, but they only measure conditions at the surface of the Earth. And the atmosphere is three-dimensional, and you need to know the three-dimensional structure of the atmosphere if you're going to forecast the weather, if you're going to understand what the atmosphere is doing. And we get information in the vertical from weather balloons that get launched, but they're only launched from manned stations. And so we really do have a very incomplete picture of the three-dimensional state of the Antarctic atmosphere. So I think it's still a large data void.
Is there any way to get sounding data from without there being a person? Really?
Yes.
Oh.
So there are a number of different methods that you can get profiles of temperature and moisture from satellite observations.
Okay.
The problem with that is that a lot of the methods for retrieving those profiles from satellite data work well in the tropics and the mid-latitudes and run into difficulties over the ice-covered Antarctic continent. A lot of them, to work well, they need to distinguish between when they're looking through clear skies and cloudy skies, and a lot of the techniques for distinguishing that are based on having a bright cloud and dark ground. And here, of course, we have bright clouds and bright ground, and so that separation of clear and cloudy pixels in the satellite view is not an easy task. It makes it hard to retrieve the soundings well.
And what is it exactly that's been your research in terms of developing these